Okay, welcome everyone to today's computing seminar. Very excited to have Nastacia from Goodwin Lab talk today about some the basics and tips and tricks, I believe, on how to use the SimBA software for video behavioral classification. So without further ado, Sasha, you can take it away.
All right. So obviously there's a lot happening in the world today. So here's some protest information for tonight. I also just want to say thank you to Avi and the Brucas Lab crew for kind of organizing a group going over. This meeting will be recorded if you plan to leave early. Also, if you have any questions, just feel free to either jump in or drop them in the chat, and we'll be keeping an eye on them. Like we said, so I'm a fourth year grad student in Sam Golden's lab. I worked to create simple behavioral analysis, which is an automated behavioral classification program with Simon Nelson, who was one of our old postdocs. And I've kind of been one of the de facto pose estimation people since we house the NAPE computational resources. So I kind of just wanted to go over our basic pipeline and kind of tips and tricks and conceptual guidelines for how to think about these different pipelines. And so in a very broad way, when Simon and I started working on this, we knew that there were all of these kind of open source pose estimation tools coming out, like Deep Lab Cut, Sleep, Deep Pose Kit. And our goal was to take input videos of socially behaving mice, figure out where they were in a video, and then extract a bunch of features. So I'll be talking about terminology in a minute, but basically calculating a lot of different things about what the mice were doing in relationship to each other, and then using machine learning to automatically figure out what they were doing. And so my aggression is all based, my aggression research is all based in this 2-mouse model. So I have a subordinate C57 and a big white CD1. And so this is SimBA at work. And so what we get out of this are Gantt plots. We can see the behavioral overlays of when the animals are attacking. We get frame by frame probability, and then we get kind of all of this basic information about velocity, total movement, and kind of number of outs. And so it took a lot to set this up, and it takes a fair amount to get it working, but people are using it successfully. And so we got the preprint out in 2020. We're still working on the real paper, but we'll get that out soon. And so Simon has left us for industry. Sophia graduated and JJ finished with his master's. And so I'm the only one left in lab, but Simon still does quite a bit of support for the program. Okay. So just as an outline of kind of the full talk today, I'm intending for this to be pretty conversational. So if you guys have questions, feel free to jump in. But I'm hoping to start with some terminology to make sure that we're on the same page, and then going over some very broad pose estimation basics and kind of, how to make a good training set for machine learning and what we look at to do things efficiently. And this is going to include frequently asked questions that people usually ask me when they're starting to use pose estimation, Deep Lab Cut tricks, because this is the software that I use. So it's what I'm most familiar with, training sets, and then kind of talking about how to make good behavioral classifiers and how to do that in SimBA. Okay, so for some basic terminology, I'm going to be focusing on the 2-mouse model just because it's what I use and I'm most familiar with. But basically, if you can put whatever you want in there. We have people using this with moths and zebrafish and all sorts of crazy things. So throughout the talk, when I'm talking about pose estimation and pose points, I'm talking about essentially the XY coordinates of each of these points on the animal. And so XY coordinates of 0.3, which is mouse one's nose. Okay. When I talk about features and calculating features, I'm talking about the relationship between these pose points. So this can be things like distance between 0.3 and 0.10. This can be the area of the polygon formed by these outside points on the mice. This is looking at their shape, movement, and relationship to each other, both in static frames and then over short rolling windows. So we have features that are total distance moved over the last half a second. Okay. When we combine the pose estimation information with features, we start to get training sets. And so this gives us frame by frame information on what the mouse are doing. So this is like in frame 2, we would have all of those X and Y coordinates. We would have info on, nose to nose distance, movement over the last 300 milliseconds. And in SimBA, we've created a feature set. So we calculate about 500 different features per individual video frame. And so we get these massive, massive training sets that we use. For today, we're going to be talking about supervised machine learning. And so in supervised learning for behavioral classification, we include annotations in these training sets. And so this would mean that in frame 2, there is an attack happening. In frame 3, there's not an attack happening. And then once we have this whole data set together with these annotations, we can feed them into machine learning algorithms that are going to try to parse out what makes a frame positive versus negative. And the output that we get is something like, in this frame, we have a 5% chance of attack, but in this frame, we have a 95% chance of attack. And I'll be going more into random forests, which are the type of algorithm that we use in future slides, but this is like a very broad overview of the terminology. So getting into supervised machine learning, it's really important to understand that this is a very iterative process. And so when I'm going through and making classifiers, and that can be either like deep lab cut models, this can be behavioral classifiers, kind of anything supervised. This is a combination of annotating new examples, training and checking, and then correcting outliers. And this combination of new examples and correcting outliers is really important for efficiently making good models and titrating. So I'm going to start going into kind of the questions that I get when people start using Deep Lab Cut. And SimBA is compatible with kind of any of the pose estimation stuff. So again, like Sleep, Deep Lab Cut, Deep Pose Kit, Bento. There's several other ones. I'm going to talk about Deep Lab Cut just because it's what I started using and it works well, so I'm probably not going to change. So we get a lot of questions about filming conditions. All of these filming conditions are fine for Deep Lab Cut. So we have kind of the normal home cage. This is pretty high resolution, but we have all the bedding in here. We have the weird lighting in the operant box. We have this reflection. And then we have kind of this low resolution blobby mice in an operant box. This model will take more effort to train than this model, but they will work. So basically kind of the rule on your filming conditions is if you can see it, Deep Lab Cut can see it. Okay. And so as many of you know who do behavior, you don't usually have like these nice clipped cropped videos coming out of the box. So here's an example of some of my reunion testing. So I have 4 different arenas. There are 2 mice in here, 2 mice in here. This mouse is like flying through the air and you can just see this guy's nose. And so kind of the first thing that we wanted to do with SimBA was get these videos into shape for use in Deep Lab Cut. And so we made this whole video pre-processing tool, which has been really, really useful for me. And so basically you can take an entire folder of videos, you can crop things down, you can shorten your videos to time when like just during your test time, downsampling, change your FPS. We also have options to convert to grayscale or contrast enhance and then adding frame number. We also have, it was a major fight to get this put in, but you can also enter your start time for your videos, and you can say add 600 seconds if you always want a 10-minute video, and it'll just auto-populate this for you. In the tools menu, we have a lot of kind of other weird random things that are fun to use. The most useful for me are multi-crop, so breaking those 4 arenas into 4 separate videos, clip videos into multiple videos. And so I do a lot of operant work with 12 trials. So I split my 12 active trials into 12 videos, and then generating kind of little video examples. So basically I take my raw videos, I use this to clip them all into just the things that I want Deep Lab Cut to see. And for cropping videos for Deep Lab Cut, you want to crop your videos as small as possible to reduce computational expense. It goes a lot faster if you have a smaller video. Okay. So when we're thinking about making a training set, like how to choose videos and how to choose frames that we're actually labeling, I think that it's really helpful to think about what big data means in kind of computer science versus in behavioral neuroscience. So If we look at ImageNet, which is kind of a huge, it's a huge image data set that's actually kind of the backbone of a lot of things that you use in Deep Lab Cut. But this is 14 million, as far as I know, unique images. So if you 14 million like biological replicates or, replicates of pictures of violins, whatever. But in neuroscience, we often have tens of animals per group. And if you think about making a training set, so training your image to understand what a mouse looks like, you don't want to train it all on one mouse because it will learn what that mouse looks like way too well. And then we get a really big problem with overfitting. And so if you are only going to annotate 100 frames, it's always better to annotate 10 frames from 10 animals than to annotate 100 frames from one animal. So you really want to maximize biological replicates here as much as possible. And then of course, going back to this, if you have different lighting conditions, you want those represented in your training sets also. Okay. We also get people asking how many points to actually label on their mice. And I think that it's really important to recognize that when you create a pose model, you are performing dimensionality reduction on your animals. And so while we can see this whole video, what we're actually feeding into SimBA or any of the other behavioral classification metrics are basically just these little skeletons. And so if we watch this video, I can gain a lot of information about attack here and the way that my animals are moving around each other. But like if you were looking for reaching behavior, obviously the paws aren't annotated, and so you wouldn't be able to see that. And so I think that it can be really helpful to kind of draw out these dots and look at the minimum skeleton that you would need to identify your behavior of interest when doing this. Okay. Other things that are really helpful. So you'll notice that all of my videos are filmed from above at 90 degrees. I would really recommend filming from above or below for Deep Lab Cut. You can try to film from the side. In my experience, Deep Lab Cut loses a lot of pose points as the animals turn around, and it mixes up left and right on the animal. There are a few folks who have this really cool setup of filming from the side, but they have a mirror system to also film from the bottom. I'm excited to see how that works. I don't know if it works with the pose estimation yet, but we're working on it. But if you have the opportunity to film from above or below, your life will just be much easier. Okay. For actually labeling body parts, you have to be very, very consistent. And so this is my 7-part pose model. So I have the nose, ears, 3 across the back, and 1 on the tail base. So the side points always go on the hips for my animals, and I always put them half off the animals so that you have the contrast between the fur and the background. It doesn't really matter how you're doing this, just be consistent. The right side is always the mouse's right. If you're having students do this for you, triple check that they know their left from the right. One time I had to spend 5 days going through and fixing sides on an animal. That was a really, really bad week. If you can't see a point at all on an animal, don't label it. So here we have just the right ear, nose, right side, and then tail base. For my specific work, I think it's really important to keep whole shape on this animal. So like how fat it is when it's standing up. And so I have nose, spine, and then these side points aren't on the hips like they would normally be when the animal's flat. But I really just want to keep information on the full size of the animal. So where you're labeling can change a little bit depending on what information you need fed into your model. Other things. So I tried for a long time to label tail ends, and I never got high performance from it. I think that if you want to label tails, you need at least 3 points. You need base, a point in the middle, and a point at the end. You may need more. You'll just have to try it. And then for trying to figure out what is good enough, Deep Lab Cut has a lot of different performance metrics, and I think so do the others. I always think that it's easiest to just start by watching these videos. And so this will play a couple times through. And what I'm looking for specifically is how much these points are moving back and forth. So how much jitter there is, if they're swapping places at all. if they're swapping between animals, and then if any of them disappear because they're low probability. Okay. And so we can see that they're pretty stable. We can see that there was a jump when the animal walked under the bar. Also, I like this color scheme because I think they look like little clowns. But for the most part, everything is staying where it should be, and there's minimal jitter. We do have some options in SimBA to deal with missing data points and smoothing. So if you have a lot of jitter, we have like a Gaussian smoothing option. I really recommend putting in the time to make a good model, and using these just as kind of finishing touches. Because you really, if you put garbage pose estimation in, you cannot get good behavior out. Okay.
I have a quick question. So
Yeah.
when I use either sleep or DLC from a top video, it's really hard to see the pause of the animals. So were you just like based on your estimation where the pause is, you know, when they were hidden in their like little body, or like what's your effort trying to make sure that you were actually getting all those 4 limbs?
So if I'm specifically doing work with limbs, I would recommend filming from below to get those 4 paws. So a lot of people who are doing kind of bulk social behavior like I'm doing, film from the top and just look at the body shape. But if you're looking at eating behavior, feeding, grooming, it's really preferable to film from the bottom. Otherwise, I would recommend putting points on the shoulders and the hips. And then even if you don't get the pause in all of your videos, you'll still get some of that, like that skeleton movement on them.
That makes sense. Yeah. And I was also wondering if you have a recommended like minimum frame per second for videos that you would, you know, consider setting up the recordings.
Yeah, so that's a really good question. And the answer, unfortunately, is that it depends a lot on what you're looking at. So for social behavior, I film at 30 frames per second, and that has always been fine. If you're looking at really fine movement, like, you know, chewing, any kind of reaching task, you may want to film at higher FPS. One thing that we did starting out is we filmed our videos at 80 FPS, and then we actually have frame downsampling options in SimBA. And so we started with this crazy high FPS and realized that we just didn't need it. And so we broke it down and we realized that we only needed 30. And so when you're making your model, you can go through and try it with a small set of high FPS videos, and then downsample them to see what gets you performance. And then I'm sorry, what was your other question beyond FPS?
Oh, and another thing I noticed when I was doing this is like, especially when mice are moving super fast, it was like super blurry. And so when I was training the model, I would pick the frame that, you know, I kind of really clearly see where the parts that I wanted to label, and that could create a bias, right? Because the training frame is the one that I have confidence in, and I try to avoid picking any fuzzy images, and those are the ones that actually mice were moving. I'm just curious, like, does that would be a concern if the mice is just moving fast a lot, or you think the algorithm is still picking up when the mice is moving fast and getting fuzzy during those?
Yeah, so there are a lot of considerations there. So all of our cameras use global rather than rolling shutters to actually take images. And that can help decrease, as far as I understand, that can help decrease the blur a little bit. If anyone knows a little bit more about how cameras actually work, that would be helpful. Higher FPS can also help get you more frames that are really clear. When I'm using Deep Lab Cut, at least, I basically load in, you know, as many little video clips as I have. So I'll try for, you know, 10 2-minute clips from 10 different animals. And I just use their K-means and I use their automated options, and I pull those frames and I just label those as best I can. because you're definitely right that if you don't label any blurry frames, Deep Lab Cut will not recognize that as a mouse part. And so you can choose your frames, but then if there's some that you just can't label, you can skip those and then go back and try to fix it in outlier correction. Okay. Yeah, and that's where, yeah, I think that the process of new frames that you're sure about and then outlier correction, when you say, I don't know exactly where the mouse's nose is, but I know that it's definitely not where Deep Lab Cut put the dot, and moving it closer can be really, really helpful for getting it working.
I see. Thanks.
Yeah. Okay. One other thing. So if you're using Deep Lab Cut on the NAPE computers, I have found that when you're creating a new project, if you don't hit copy the videos, you can get a lot of really weird server permission errors. And this is not selected by default. So when you make a new project, you want to actually make sure that your videos are copied over. Otherwise it creates a symbolic link, and like it can't get things off servers, which is really frustrating because usually you don't recognize that problem until a couple weeks down the line. So just make sure you always select this. And then in general, for the pose estimation stuff, for any of these open source platforms, everyone has really good documentation. And so these are links to kind of the direct documentation for Deep Lab Cut, Sleep, Deep Pose Kit, Mars, including Bento, our documentation. And then a lot of people use Gitter, which is like an instant messaging service. It's really helpful. I woke up the other day to 78 messages about ROI problems on SimBA, which was exciting. And then also you can raise GitHub issues. So if you go to someone's like main GitHub, there will be this issues tab. And usually if you click on that, they'll have little instructions like, please provide us screenshots of the problem, which buttons you were trying to push, etc. And so if you're using open source platforms, it's really good to get comfortable reaching out to people and asking for help, because we all made these programs because we want to help people. So please don't be shy about that.
Hey, Nastacia.
Yeah.
I have a question. This could be answered after you start explaining the SimBA portion. But at a certain point, if you don't see good results in the behavior classifications, do you ever go back to the Deep Lab Cut portion to like double check the pose estimation? Since I would assume that will affect the annotated model.
Yes. So I have this big scary flowchart that I actually took out of my presentation because Sam said I'm never allowed to just like show that to people because there are too many boxes. But a big part of this is like,
I would love to see that though.
Yeah, I'll bring it up for you guys. But a big part of this is when you are visualizing these behaviors, if you see a frame, so like if you're scoring attack and you say, okay, I'm watching my video, I see the pose overlay, I see when it's scoring attack and when it's not. Is there always something wrong in the pose where it's missing attack?
I see.
And in that case, you would want to go back and say, okay, I'm gonna fix the pose. And so that gets into kind of the outlier correction steps, the behavioral classification, where you really want to look at what is missing and say, okay, what's the theme and what's being missed here? Is it like I just didn't have enough of that specific behavior in my training set, or is there actually something wrong with the data that I'm feeding into my behavioral classification?
I see. So yeah, I guess you're gonna re-explain that during the outlier. Yeah. Okay, gotcha.
Yeah. Okay. Does anyone else have kind of questions about the pose estimation stuff? So all of these different platforms have like kind of practice tutorials that you can go through, and I really recommend going through and doing that. I can help some with Deep Lab Cut stuff in the lab and some kind of like general computer errors, but I'm not a strongly computational person. So I recommend definitely reading through their documentation and hitting them up for help directly if you need it. Okay. So moving into SimBA, some very basic info. So we only maintain one version of SimBA right now, and this is the SimBA UW TensorFlow development version. There's still other versions available because Simon is very attached to them and won't take them down. Don't use them. So installing this is very easy, and updating is very easy also. So it's all pip install. If you're using any of these open source pipelines, they all need to be installed in different environments because basically they all conflict with each other because they need different versions of things. And so I'll show you guys in a minute, at least on the NAPE computers, the different Conda environments that I have set up and how to access those. Okay.
Hey, Nastacia?
Yeah.
There's a question in the chat.
Yeah.
It's
so there is a no TensorFlow version. I don't know what functionality it still has. So that would be a question we'll need to touch base with Simon on that. We definitely don't recommend that people still use it. Sorry, someone's jumping into my computer. Okay, so you do not need a GPU to use SimBA. The GPU is purely for pose estimation. The better computer you have, the faster everything runs, as is kind of generally the case. But Simon and I both use this on our Macs, and then it has compatibility with Linux also. In Linux, you're going to get more path errors because of back versus forward slashes, but I think that we've ironed most of those out at this point. We have a YouTube channel that I actually just found out about last night. That has a playlist of kind of all of the different weird visualizations and things that you can make in SimBA. It's kind of fun to go through. And then, yeah, I'll show you guys kind of the Anaconda environments in a little bit. Okay, so we also have, I've heard that our GitHub page is very overwhelming. So I'm just going to actually pull that up for a second to show you guys. Okay, so we have our SimBA GitHub page. If you scroll down, we have a lot of announcements at the top. But if you just scroll past those, we have all of these different tutorials. And so this is helpful for if you are starting completely from scratch, if you are using an old classifier on new data, et cetera. So we have all of these different step-by-step projects that you can go through, and it has little videos showing you where all the buttons are and what to actually hit. And then we have tutorials for kind of all the different use cases that we have to. And other things, so all of the models and everything that we've made are available on Open Science Framework, and you can also just reach out to me and I can kind of show you where things are at. So if you go to our new documentation page, which is down here, we actually did a full tutorial for a conference pretty recently. And so this workshop tutorial has kind of a little data set to play with, and you can learn how to annotate behaviors in SimBA, and there's some video information too. So since we have all of that available, I'm not really going to go through like button by button and show you guys how to do everything until the end if we have time and people want. I'm going to kind of talk about like conceptually how to make good classifiers and how to arrange things. Okay. So the very basic pipeline for SimBA. So we talked about that terminology where we have our videos, we have pose, we have features, and then we use those features in machine learning algorithms to make things. And so the basic pipeline of SimBA is you have your outside pose estimation, you import all of that information into SimBA, you have to calibrate distance in here. And so you have a little GUI where you have a known distance, like my cage is 19 centimeters long, and you just click the top and the bottom of your cage and say it's 19 centimeters to get all of your distances calculated. So it's okay if your camera moves between filming. You can correct outliers in your tracking if you want to, and then you extract features. And all of these are kind of auto-populated sheets that go into different folders for you. Again, we have all of these scenario tutorials also. Okay, so when we started this, it was really an opportunity to kind of alleviate all of the things that have been annoying me about doing behavioral neuroscience research since I started in 2012. And so we have the video batch pre-processing, so we can add frame numbers, crop and shorten, import tracking. This is compatible with all of these different pipelines. We have an ROI system where you can, which I'll talk about in a minute. You can annotate videos in here. So we have keyloggers. You can create your classifiers and actually run all of your videos. We have several validation steps. You can pull descriptive statistics and make Gantt plots. And then we also have some explainability modules, which I wasn't planning on talking about today, but I can. And so I think it's good to kind of go through each of these different things today. Okay. So for the ROI feature, this is really nice because you don't have to make classifiers to use this. So you can just use this on your raw tracking data. So like you normally would in EthoVision or whatever, where you're just making your ROIs, you can make all of your different ROIs in whatever shape you want. You can move them around. You can apply them to new videos. If you're doing this, you really need to make sure to read the documentation and make sure that you are hitting save ROI at the right times, or it won't save it and you'll have to redo them and you'll be very sad. Once you have all of your ROIs drawn, you can just really rapidly analyze your distances and velocity. You can make heat maps with a bunch of different color schemes, generate your plots. You can do kind of all of this basic analysis without paying $10,000 for an EthoVision key. Okay. So when we actually open SimBA to make projects, so you open SimBA. Okay. So all of these are installed in different environments. So I'm on NAPE 2 right now, which is like kind of the shared NAPE computational resource. I suggest opening Anaconda Navigator and looking at which environments are installed. I usually keep an old version and a new version of things just because we've had some instability with like the latest Deep Lab Cut update. But basically for SimBA, you just open terminal, type in SimBA, this will open. We have our little splash screen, and then this is it. So once you start making this, you just go to File, Create a New Project, and that's going to take you to this project configuration page. Okay. So once we're in project configuration, there are a couple things that you need to know to use this effectively. So when you're making your project names and kind of when you're naming your videos for use in open source pipelines, you want to avoid spaces, hyphens, periods, and don't start with a number. A lot of people who aren't actually trained in coding who make these pipelines create a lot of weird incompatibilities with these things. So try to avoid them. For the number of classifiers, even if you're just using this for ROIs and you don't plan on classifying behaviors, you have to enter at least one or it won't run things. So enter one, hit add predictive classifier, and you can just type in random letters in there if you want to. Most of the images we have in here are of mice. And so we have post configuration set up for several different settings here. So I think that we have 3-point like single mouse models. We have the 8-point model here with 8 points per animal. I use 2 animals, 14 points. But you can also make your own post configurations and your own feature lists. So you aren't in any way constrained by our affinity for mice here. So you're going to do all these things and then hit generate project config. You are able to, so if you have your experiment, you only want to analyze one experiment and you want to make classifiers for that experiment. So you want to make 5 different classifiers for that experiment. You're welcome to just do that all in one project. I really don't recommend doing that because it can be kind of a nightmare to work with because of that iterative process that we talked about. And so the way that I organize everything is that I have different folders for each behavioral classifier that I'm training. And I'll talk, this is part of random forest that you have to make a different classifier for each behavior. And you'll notice that like in my attack classifier folder, I have 6 different versions of attack while I was titrating that. In defensive, I had up to 13 that I was making. And so I go through, I make my classifiers, I get them really well trained, and then I pull my classifier file, which is this .sav file, and I use that in experimental projects. So my classifier projects are separate from my experimental projects. And when I'm actually analyzing experimental data, I'll go through and I'll say, I want 3 classifiers. I want to analyze for attack, defensive, and escape. But this is it's much easier to manage if you keep these separate. But you don't have to. Okay, so these are the additional tabs on the generate project config info. You do want to import your videos into the project folder for visualizations. You have to import your tracking data for SimBA to be able to work. You do not want to extract frames into your project folder. There's still a lot of documentation that says extract frames. Don't do that. It takes forever. It takes a ton of space. You don't need them. Just don't. I'm trying to get us to remove that tab, and it's been difficult. Okay, so once you have all of this done, the basic folder structure here, so you go through and you hit generate config, you're going to get all of these different folders. So you have your models folder, which has all of your behavioral classifiers and all of their validation information. And then you have your project folder, which has your project config file. So when you load a project into SimBA, this is what you need to get, is your .ini. And then in your CSV folder, the input folder is where all of your tracking ends up, and then it kind of bounces down through these folders. So your input folder is your tracking information, goes through outlier correction, then we calculate features, and then you can annotate it. So your annotation sets end up in targets inserted, or you can analyze things, and that ends up in machine results. So this is just kind of the general structure, and being able to work with this a little bit is helpful. Everything in this main folder will be analyzed. And so if you load videos in here, but you don't want them analyzed, you can just throw anything you don't want analyzed in a subfolder. So open features extracted, make a temp folder, throw anything you don't want analyzed in there, and SimBA won't touch it. So that's really helpful to know. Okay. So does anyone have any questions about that so far? Okay. So I've talked a lot, I've mentioned random forests a lot and the different classifiers that we're using. It's really helpful to understand how random forests actually work, because it's a little bit counterintuitive with how we typically score behaviors like as ethologists. So random forests are called random forests because they're forests of little decision trees. So I always use 2000 trees for my classifiers. Random forests are binary classifiers. So they can tell you that an attack is likely to be happening or not likely to be happening, but they can't tell you the difference between an escape is happening or a defense is happening. And so that's why we have to make those separate projects or those separate classifiers for each of our behaviors. Random forests also do not inherently incorporate temporal information. And so we're really used to thinking about behavior in bouts. And so if you're watching a frame by frame video and you have a 5-second attack, there may be breaks in there where animals aren't actually biting each other for a couple seconds at a time. And if we're just hand scoring that, we would call the whole thing an attack. We can't do that in random forest because the way that this pulls data out is on a frame by frame basis. And so if we look here, so for my attack classifier, I have each of my individual frames from all of the different videos that I've scored, my 500 columns of features and my annotations, and then I have about 60,000 rows in here of individual frames. And so each decision tree is going to pull a different set of individual frames. So it may pull frame 4 from video 8 and frame 1 from video 2. And then it pulls random features out of here also to make decisions based on. And so this means that it is very, very important to score your behavior on a frame by frame basis. And so for every single frame that you're putting into your training set, it's really important to say, okay, is an attack happening in this frame? Yes or no? And for the feature set that we use, we've incorporated some temporal information. So I've talked about those rolling windows. So each frame that we use in here may have about a second of information about the past in it. So, over the last second, how much has an animal moved over time, but you can't score based on bouts like we normally do. And then, yeah, that's because of the randomly bootstrapping out frames and features. And then Random Forest put out a probability per frame. And so we talked about kind of that like 5% chance of attack versus 95% chance of attack. And so the threshold for yes versus no is automatically set at 50%, but sometimes you end up changing that. And so because it's equally important to teach your classifier what a behavior is versus isn't, sometimes your classifier may be really sure about what a behavior isn't, but it's only 70% chance, 70% sure about what a behavior is. And so this is what the probability plots look like. So for a good classifier, so this is my attack classifier, we have these really high peaks. At 100%, we have this really low baseline at 0. So this is a really good split between like definitely attack and not attack, but we do have some of these in here. And so basically what we need to do with thresholding is go through, check that all of our 100s are definitely attack, but then we can also come down here and say, okay, but is this an attack? Is this an attack? And we may end up setting the threshold somewhere around, 0.38, depending on what we're seeing there. Okay, so with all of that information, the goal of good classifier training sets is to have examples of all of your types of behavior of interest. So all of the different ways that an attack could look, including kind of those big, like long wrestling bouts, individual slaps to the face, etc. Like you want your classifier to know all of the different ways that attack can happen. You also need your classifier to understand that animals rearing up and sniffing each other is not attack. And so
sorry to interrupt. So are you talking about all of the types of attack behaviors you're gonna make one model?
So for my work currently, yes.
Okay. So that's the meaning of all examples of all types of attack behavior should be annotated as attack.
Right.
In one, and then you have to include all types of attack in one.
Right. But it can be, so if you want separate classifiers for.
You can also make a separate classifier.
Yeah.
But that's good to know that you can kind of merge it to one classifier.
Yes.
Yeah. Interesting.
Yeah. And so like I was really lazy with my allo grooming classifiers. And so you may know that there's kind of like casual allo grooming, and then there's vigorous allo grooming with animals. And so like I originally was trying to make classifiers for the two of those, and then I decided that it wasn't worth it for my research, and I just combined all of those annotations, and now I have like a global allo grooming classifier.
Interesting. Okay.
And so when you
sorry, Nastacia.
Yeah, go ahead.
Do these classifiers, do you have to take into consideration which mouse is the one initiating the behavior, or is your classifier doing no matter which mouse, 1 or 2 is the one doing the behavior?
So you can do either. I always make directional classifiers because I'm interested in kind of the reciprocal social interactions. And so I always have this set up so that I have one aggressive mouse and one subordinate. And I'm specifically looking at aggressive behavior versus coping behavior on the part of the other mouse. But you can definitely just make classifiers that are any attack in a video that is counted as positive.
So in other words, so for example, attack behavior involves the behavior from the two animals, right? So if you make a classifier for attack, it will use information from both of the poses or both of the features extracted from both of the animals. But for like self-grooming or stuff like that, if you want to make a model for grooming for one of the animals, there will be like random noise coming from the other animals. Is that correct?
Yes.
Okay. And so
but let me, so when you put your pose estimation information into SimBA, and like even when it comes out of Deep Lab Cut, you have information on which mouse is which. And so you'll have information that's like, okay, the nose of mouse 1 is here. And so all of that information stays split. And so if you have multiple mice in here, we basically have a double feature set. And so we'll have total movement of mouse 1, total movement of mouse 2, and then total movement of the two combined. And so the way that random forests work here is, so we have the full feature pool, which includes features for both animals. So like you can see, well, I don't know if you can see here, but you have mouse 1 with over the last however many seconds.
Okay.
So each decision tree is going to pull out the random assortment of frames, and then it's going to basically sort the features that it pulled based on which gives it the best split between your annotated attack versus no attack. And so kind of the best feature that this tree has is, distance over 750 milliseconds, rolling window. And so it's going through and it's just, so this individual decision tree is just finding this value. So like 60% of the total value is where it splits. And then you have these different splits running all the way down. Random forests are really helpful because they're more inherently explainable than a lot of other algorithms. And so when I have 2,000 of these trees, I can go through and I can say, okay, across all of these trees, which of these features were most helpful in making the splits? And so you get a ranking and you can say, okay, when I pull my attack classifier, what were the top 10 features that it was considering when it's determining attack versus no attack? And so that's a way to look at, okay, is it only relying on body whole shape of mouse 1? Is it looking at total distance of the two animals? And so that's how you can kind of understand what it's actually using, and that's how you can look for confounds.
Okay, so I guess going back to my question, so because of this, the way the random forest algorithms works is that, so probably if you are interested in a behavior that's coming from only one animal, a feature that is coming from one animal will just do a good job, and then it will be okay. My worry was that because if there's one animal doing a certain behavior, and whenever that animal is doing something, the other animal will be randomly moving around, you might have to have more annotation frames for that type of behavior, but that's not the case.
And so yeah, so you may, if you have a training set that has only one animal grooming, and then you add in new videos that have two animals grooming, it will probably get confused.
Yes.
But in that case, you just add examples of animal 2 grooming, and you say that those are like not grooming, and you retrain your model, and it really easily splits, and it understands that, okay, I'm looking at these physical parameters, but only in mouse 1.
I see. Got it. Thank you so much.
Yeah. And we do have ways to switch the directionality of classifiers, because like I went through and I made all of my classifiers. So I have my white CD1 who is fighting against the black C57. But we wanted to switch and say, okay, what if mouse 2 is fighting against mouse 1? And we have some ways to go through, like we have a button that says, I think, directionality swap. And you can use that to switch directionality so that you don't have to annotate another full training.
Oh,
set.
nice. You can treat the animal 1 as black instead of
exactly.
white.
Yeah. And I'm guessing that so my animals are typically very different sizes. So I'm guessing that I would need to add in at least some examples of the switch frames, just to say, okay, now it's a small mouse attacking instead of a big mouse. But since this is iterative, and since you can just throw in, I'm talking like adding in 30 attack frames and then retraining, not adding in 30 new videos.
Okay. Yeah. That's so nice.
Okay.
By the way, it's 10 minutes till 5.
Okay.
You're welcome to keep going after that. But
yeah.
just a reminder.
Yeah, I think that it was important. Sorry, my mouse isn't really working. Okay, so I just want to go through again, like main operational definitions. So we've talked about frame by frame annotation and how important that is. And then, so for the frame by frame annotation, each incorrect frame, whether it's incorrect in a positive or negative direction, can negatively impact performance. And so it's really helpful to make kind of these operational definition charts, especially if you have multiple people scoring. And so this is something like saying, okay, so in defensive, I'm specifically looking at my black C57 fighting back against my white CD1 and having a description of this behavior, a description of the exact start frame, what you see during the duration, and then the end frame. And I found that that's a really helpful thing to have, especially if you're scoring entire videos. So I get a lot of questions about training set sizes and how much annotation you'll actually have to do. For my attack classifier, so F1 bifold cross validation, this is kind of a standard machine learning performance metric. So the higher the F1, the better your classifier is at detecting true positives and rejecting false positives. And so here, this is a number of frames that I annotated. And so this is total number of frames. So there were some videos in here that didn't have attack in them at all. And so for attack, we can see that I labeled about 60,000 frames, and this is at 30 FPS. And Sam told me to stop labeling around here, which I probably should have. But you can see that the performance really tops out after a while. Whereas defensive and escape are much less distinct behaviors than attack. And so you can see that even with kind of the same, with the 20,000 total frames annotated, I have big differences in performance here. And so the more subtle the behavior, the more you have to annotate. But still, for this attack classifier, even though I way overtrained it, this is only 30 minutes of positive behavior. For a lot of these, I'm adding 2,000 frames, which is about 1 minute of positive behavior. So it depends a lot on how distinct the behavior is, but you really don't need to do a lot for these to get them working well. Okay. That's kind of like the conceptual stuff on labeling behavior. The rest that I have is kind of GUI stuff. So we have a couple different ways to label behavior in SimBA. So you can import third-party behavioral labels. So if you have any old behavior sitting around in Boris or Solomon or Mars, you can import that straight in. We also have kind of a keylogger that we can use to actually open videos in SimBA and label them. And then pseudo labeling is nice because you can just use an existing classifier, run it on some videos, and then go through and correct whatever you're seeing. And so this is a good way to go through and correct any outliers that you're getting. Advanced label behavior doesn't work yet. We're working on that. So just don't use that yet. A couple other things about the GUI that are really important. So we have, make sure that you are looking at what file you need to put in here, because it's a combination of adding either the video path in, adding in the feature files, and we get a lot of people who have errors that they can't get past just because they're putting the wrong thing in here. And then when you're actually labeling behavior in SimBA, if you don't label a frame, it defaults to negative. And that's what we're trying to fix in this advanced behavior labeling, but we're still working on that. Here's just a quick overview of how to label behavior in SimBA. So you can jump through frames individually this way. Again, make sure you're following the directions for when to hit save and advance to next frame. Otherwise it won't save. You can open the video and play it here. This is pretty useful. And then all of your annotations are going to be in those project folders, and they'll be in targets inserted. And then what those files actually look like, and this is also really helpful for correcting things, are you have your frame number over here, You have the full database of like 500 rows with your pose information and with all of your different features. And then you have your annotations with ones as positives and zeros as negatives. And so if you have frames that you aren't sure about in here, like I don't know if that animal was actually being defensive or not, you can just delete these rows and then the model won't actually use them. So that's, I do a lot of work going through with outlier correction and kind of working directly with these sheets. We're trying to add this capability into the GUI, but it's hard because Simon's gone and I don't really know how to code. So, okay, that's how you go through and you make a good training set and you've annotated all of your behavior. And then I just wanted to include some information on model settings. So when you go to train your models, we have this metadata file with this acronym that stands for behavior that will get you a Nature paper. So you just open that CSV and load it, and you have all of our defaults loaded in here for how to work with the random forest. And so this is how many decision trees do you want? What's the max number of features you want pulled? If you click on this link in the GUI, it takes you to a full description of all of these. The defaults work really well for me for social behavior, but we designed them based on social behavior. So you may have to change these over time. The only things that I usually change here are the undersample settings, and I'll show you how to know when to do that in a second. We also have model evaluation settings at the bottom, and this is a bunch of different visualization information. And so when I start making my models, I just check generate the metadata file and generate classification report. Because when you're first starting out, you're going to need to probably work with the undersampling settings, and you want this to go really quickly. So the classification report looks like this. So this is a classification for a pursuit classifier. We have frames that were counted as positive on the top, negative on the bottom, and then we have precision, recall, and F1 here. And so these classification reports aren't great for behavioral neuroscience data sets. And that's because we typically have multiple frames from the same video in here. And so this means that even though the random forest is automatically taking out 80% of frames to train itself on and then 20% to test it on, there's similar frames in that 20% set. So it's already seen that mouse attacking, even if it hasn't seen that exact frame yet. And so these performance metrics are almost always going to be an overestimation of how well your classifier is going to perform. So I always recommend annotating a few videos and leaving them completely out of the training set so that you can go through and kind of more accurately look at generalization to new videos. And so I also talked about the undersampling settings. So you can see that this is 0.852 here versus 0.80. And the F1 score is a harmonic mean between these two. So we always want to adjust undersampling until we get these to be pretty even. And undersampling is useful because random forests are sensitive to biased data sets. So when you make your training set, ideally you would want to have an equal number of positive frames as negative frames. But if we're going through an annotating behavior, that almost never happens. Like you should never have an equal amount of attack frames as non-attack frames, because that's not really what animals do. And so one way that we can get around that is to go through and take the negative class and just take less of these frames out. And so basically I run my classifier for the first time. I look at this, this difference, and then I go through here and I can just change my undersampling settings. And so I would type in random, and then for the undersampling ratio, it depends on how bad that difference is. I usually just make multiple classifiers ranging from like 0 to 8 undersampling in steps of 2. And so you can train multiple classifiers by updating this, hitting save settings for a specific model, update, save settings. And this is why it's useful to have your different projects for different classifiers, because if you have 5 different classifiers in one project that you're trying to make, and you're making multiples for all of these, it kind of ends up a mess. Okay. So I run these until I get pretty equal ratios between precision and recall. And then the next way that I start to look at my performance is through that thresholding that I talked about. And so I move on to the next step, which is validate model on a single video. And so I pull the features file for a video. I select the model file that I think is good, and I hit run model and then generate plot. And what this gives me is a GUI where I can go through and I can select the high probability frames. It pulls this up in the GUI, and I can say, okay, are all of my high probabilities actually the behavior I'm interested in? And where does it start shifting into not the actual behavior that I'm interested in? And so that's one way to start setting your threshold. And especially starting out, I've never had a classifier where 0.5 is the correct threshold. So you always want to look at that. And so I use validate model on a single video. Then I do sklearn visualization, which is the video that we saw at the beginning, which is just the animals interacting with the pose points on them, and then a frame by frame statement of whether or not the behavior is happening. And my initial threshold for this is if a student gave me this video and I would tell them to go rescore it, I retrain my model. And then it's also really helpful to look at these and see if there are particular classes of false positives or false negatives, because you can go through and target those to add specifically back into your training set. So like when I trained my original attack model, I didn't have any frames of animals moving around together, so like running next to each other. And so I just had to annotate a few frames of animals doing that and add them back in as negative examples and retrain. And that fixed my model. The third validation step that we have is classifier validation, and this makes you a little montage of all of your behaviors of interest. And so this gives you which event it is, total number of frames, where it is, and then the probability per frame. And so this is another easy way to look at probability in the context of actual behavioral bounds. Here. Okay, we're over time. Does anyone have any? I can keep talking if anyone is still interested, but does anyone have any questions before they need to take off? Okay. So just to go over a few last things really quickly. Once you think that you have a model that's good enough that you actually want to use, you want to go back through, load in the meta file. There's information on how to do this in the GitHub tutorials, and you want to retrain it with all of these model evaluation settings. And so you generate your metadata file and your classification report like you did previously. But you also really want to look at feature permutation importances. And this is what gives you that information on the most important features and how much they contributed to your classification. sklearning curves help you understand, like computationally, where your threshold should be. So where's the best intersection of precision and recall here? I usually do this by eye and then adjust it with this, because these are very CPU intensive. So you cannot use your computer for anything else while these are running. And like for my attack classifier, which is gigantic, this will take 2 or 3 full days to run. Generating precision recall curves is really helpful. And then SHAP scores, I can talk to people about that if they want to, but this is an explainability metric, which gives a little bit more of a broad view about which features are most important. So as you're making models, this is the information that you'll want to report in your methods. Okay. So all of that information was about training classifiers. To actually use classifiers, again, you can just take those individual classifiers and put them into your models folder in your experiment. And then it's pretty easy to just run your machine model. And so you need to set your model settings. And so this is where you select your SAV file, you set your threshold based on what you've calculated. The minimum bout information, set that to 0. This is an old way that we were trying to account for that frame by frame probability. So while we needed to create our classifiers to look frame by frame. We still want to score actual videos in bouts. That makes sense. And so we set this to 0, and then we use Kleinberg smoothing. And just to show you what that looks like. So on the left, this is the raw output from SimBA, and you can see that attack is flickering on and off here. And so we were getting these outputs that said that we had like 800 attack bouts, which obviously is wrong. The Kleinberg smoothing just turns these into behavioral bouts as we would typically consider them. Okay.
So in this case, will the smoothing affect the value of the probability?
No.
No? Okay,
No.
so you,
Sorry, go ahead.
so yeah, I think, so I was just worried about if it's like, just like a Gaussian filter or like Gaussian smoothing, that will affect the probability score, thus the threshold, you have to reset the threshold or something like that, but it's not like that.
No. So it's some sort of infinite hidden Markov model as far as I understand it. And so Kleinberg smoothing basically, so you have your original videos that have been analyzed, and it's literally just going through and smoothing over kind of those individual out. So the probability stays the same. Nothing in your original data changes. It's just changing essentially the annotation output.
Okay.
Yeah. And as you're working with these models, like none of that smoothing or anything impacts your classifier, because you're using your classifier to analyze these videos, but using Kleinberg, changing your thresholds and everything won't actually go back and impact your classifier unless you retrain it. Okay. So once you have your videos analyzed, so here, let me show you. So running the random forest model goes through and it gives you an output. So you get that full data set per video with every single frame, with all the pose and features, and you just get your machine output, which gives you that binary yes and no based on the probability. Obviously that isn't super useful for us because that's not how we actually analyze things. So we want to go through and pull that information from each video. And we do that with analyze machine results. And so you can analyze machine results for full videos. You can do analysis by time bins. You can also pull distance and velocity information, and then you can look at classifications by ROI. We also have some like severity stuff in here. I would definitely recommend looking through the visualization page and seeing what all of this means, because you can make some pretty nice videos for presentations through this. Okay. When you are doing your video analysis, you get all of these different options. You literally just click number about events, first occurrence, all of that, and hit analyze. And what you get is a spreadsheet of every video that you included in your experiment, and then the duration and whatever else you clicked. And if you had multiple classifiers that you're looking at, it just labels it with lateral threat, total events duration, etc. Okay. This is usually the point where I pull my spreadsheets and throw everything into Prism and start actually analyzing it. We had some very ambitious undergrads who made this really nice data visualization dashboard. And so you can actually pull your sklearn data, which is that video by video output, and start to look at your group means. Again, look at the documentation on this and how to get your group set up correctly. But this is a pretty nice way to quickly visualize things if you just like need something before lab meeting to throw in. And you can look at like standard deviation versus standard error, the mean, and change colors. And it's really nice. I was very impressed when they gave this to us. Okay. And kind of the last thing that I had today, we have some outside validation that this is actually working for people and they've been able to use it, which is really nice. So we have about, I think we have 80 citations on SimBA, the preprint. This is the only paper I found so far that's actually looking at SimBA classification versus hand scoring. And it's from Tom Cash's lab. And so we're seeing that for these different classifiers, so grooming, rearing, and digging, we're seeing some pretty high, like really high correlations. here between machine learning and hand scoring. So I'm very hopeful that, a lot of people are using this and it looks like it's actually working the way it should, which is exciting. And then just some basic limitations and considerations. There are a lot of things that I want to fix in the GUI to make it more user friendly. And then inherent issues are, all of this changes quite a bit for real-time applications, and we can have separate conversations about that if you're trying to do real-time or closed loop. And then there's that lack of mutual exclusivity because of the random forest binary nature. And so you may have some frames that are classified, for example, as both escape and defense behavior. And the more similar your behaviors are, the more you have to watch out for that, which is not ideal, but we can work around it. And then just kind of the last thing, there are a ton of really beautiful options for behavioral work out there in all of these different pipelines, but kind of the same information stands. Like, you want to make your really good, widely trained behavioral classification. You want to make sure that you're very sure about the data that you're putting in as positive and negative. And you want to train it on kind of all types of the behavior that you might be seeing. And that's all I've got. Sorry, we went over.
Nastacia,
Mhm.
that was so great. I have a couple questions.
Yeah, for sure.
One is about the feature extractions. I've noticed that you guys have multiple scripts for features extractions.
Yeah.
Like, is there like a one generally applicable one, or like do you have to like tweak the feature extraction script for specific types of behaviors? Because it seemed like it's very handwritten and you have to write the script.
Yes. So it really depends on what type of pose estimation you're doing. So basically the way that we approach features, we tried to make as exhaustive a feature set as we could. And then we're trusting the random forest to go through and parse out the things that it needs versus doesn't.
Mm-hmm.
If you want to, especially for real-time applications, you can go through and like do dimensionality reduction, look at collinearity, really parse that down and say, like, we don't need movement over the last 250 and 200 milliseconds. Like, that's redundant. We don't need it. So what we did is for the 2 mouse, 7 points per mouse set, I just used the default 500 features, and that has worked really well for me.
Okay.
If you're using different types of pose estimation, you may need to think about altering those feature extraction scripts, just to make sure that you're catching all of the relationships between the pose points that you think are important.
Okay, and that I might have missed it, but is that default specified in the documentations, or does it come within the pip package that we downloaded?
So it comes with the package. It comes with
Okay.
the package that you download.
Okay.
Yeah. So if you just hit feature extraction, it will calculate those features for you. So everything in the default, basically everything in this default. So one animal 4, one animal 7, 8, and then the different 2 animal options. All of these have default feature extraction scripts. And when you choose this config, you're choosing the features that you're using.
Oh,
and you can also, so you're not locked into that.
Okay.
So you can definitely change it to add or subtract features if you want to, but we just really wanted to make this as plug and play as possible.
I see.
Yeah.
Yeah, another thing is about the outlier corrections. So like, how do you like specifically pull out the outliers from the annotated video? I think I might have missed that point. Is there like is there a function to do that?
No.
Or do you have to go through the video?
So unfortunately, right now, the only ways to annotate videos in SimBA are to either do this full hand labeling of a full video, and you use the shortened videos option in the batch pre-processing to make just little video clips that you're
Yeah.
you don't need to hand annotate 20-minute videos for this. That actually really hurts your performance because you're overfitting to that video.
Okay.
But basically right now, so you go through your videos, you can label the whole thing. You can kind of correct outliers by doing pseudo labeling. And so I may take, if I've been filming in the home cage and I suddenly want to look at attack behavior in an operant box, I'll load in my operant box video. I'll run my old attack classifier on it and then hit correct label. And it will go through and it will do its best with the threshold that I set to pull attack and not. And then I can go through and correct that information and load that whole video back into my training set and retrain my classifier. That is not a very efficient way to do this.
Okay.
Unfortunately, so what we're trying to build into advanced label behavior is to go through. And so right now I'm just doing this by hand with a lot of kind of weird Python scripts, which I can share and show you how to use. But the things that I specifically really want to look to build in are ways to correct false positives. So right now I use that video validation script that makes like the montage of all of the positive clips. And I take that, I go through my sklearn database and I sort by lowest duration of behavior. I take videos with less than 1 second of behavior and I double check those positive video clips. And usually if there's less than 1 second of behavior, it's almost all false positives. And then I literally just has a script that cuts it to just those frames that were called positive and switches them to negatives.
Yeah. It feels like if you can just like assign a NaN value instead of a false or negative value,
Yes.
it would save a lot of those kind of
Yes.
stuff. Because like I should have read the descriptions carefully, but I think I'm overfitting my the models I'm creating. But the reason doing that is that it's just I cannot define a NaN value for all that for the frames.
Yeah, and that's something that is really frustrating that I've been struggling with too, especially with my defensive and escape classifiers, because there are some, especially at my frame rates, there are some frames where an animal is switching from being defensive to running away. And I can't define that as one behavior or the other. And so what I'm doing right now is going through, I say, okay, I know that this is frame 486. I make a list of everything that I want to strike out in those annotations, and I open my targets inserted file and I literally just delete those rows.
I see.
But what we're trying to do in that advanced behavior annotation is to make all of this more automatic and easier.
Yeah.
And I'm also to get that probability plot, to get everything pushed apart. I'm really looking to make a platform where you can pull all of your frames that are between like 0.4 and 0.6 threshold and just correct those guys.
I see. So like closer to false positive or closer to
Right.
false negative. I see.
Right. So these are all things that we're hoping for. But I'm also, hoping to defend and get out of here one day. So I can't write these right now, but we're trying.
Gotcha.
Great discussion. I think maybe time for just one more question.
Yeah, and anyone feel free to reach out to me on the NAPE Slack. We can always like set up like little workshops to go over classifiers and things like that. It's easier for me to do if we can have kind of group conversations that I'm not spending 3 or 4 hours a day meeting with people about the same thing. So yeah, just let me know and I'm happy to meet. I like talking about this. And if you have any interest in helping us revise scripts, that would be amazing too.
Yeah, I think we can talk together as well to see if you want to do another one of these with like a hands-on demo. But yeah, I agree with Ken. This has been very helpful, and think you explained things very clearly and intuitively. Okay, so I guess we can finish up. Thanks again, Nastacia, for presenting, and thanks everyone for coming. I'll see you all next time.
All right, thank you.